So, hi, today I'm going to try and explain the four pillars of object-oriented programming with an help of an example. So, the four pillars, as we know, are um, encapsulation, that is providing a safety measure so that people cannot directly access a variable you define for added protection in real world. The second one is abstract class abstraction, which is we basically create structure of function we want to use but not actually define those function. This actually is used to reduce the complexity and not with when the user don't want to know is actually going inside the thing. We could simply define it and leave it and later define it so that we could easily access it function in form of directly by the function name and not the actual implementation. The third is inheritance. So inheritance is basically copying the variables and the function defined by a parent class so that the child do not have to redefine them. And the fourth one is encapsulation inheritance polymorphism. Polymorphism is of two types, that is runtime and dynamic morphism. I'll show you more while writing the actual code. So let's first go on and define the necessary uh, things we need to include to run this stdc plus plus dot h. Oh, sorry, this was yeah. Now I'm using name space std. So yeah, the now let's define our main abstract class. So let's name it class shape, and let's then go on and define it. So let there be um mm, let's define three virtual functions here. So public virtual let's give it something like virtual void print, so that like we could print the area. And let's also define a virtual function called um, let's define it double, just in case because like the if I'm defining circle as a uh, child class of shape, it would have its area in form of points. So let's define virtual double area equals to let's keep it constant. So area is equals to two zero. Same for this equals to zero. And let's also define a virtual destructor um, of the class shape. Shape is equals to default. So we have defined an abstract class, and here we are using two virtual function that we actually need to implement in our child classes. And the child classes must implement these to be following the structure. So let's define a class circle inheriting from the public um, shape. Let define um, some private for the encapsulation part. So private double. Let define a radius of circle. Always have a radius. So let define a private variable. Then let's define some public methods. So we have defined area and print above. So let's go on and use polymorphism for this dynamic polymorphism to actually override these functions and use them in the child class. So public um, void print, which takes um, print takes in nothing. So let's first define the area only. So double area constant override um, and then um, let's do return 3.14 the pi value. The area of a circle is pi r square. So radius into radius. Void print as a constant override, and let's do p out as area of the circle is. Let's do area here, and just to be it to be looking neat, so we can do backslash n for to move on to the next line. So I forgot here to define the actual circle function, the initiator. Uh, so what I will do is um, circle mm, takes in double r was to radius here, and yeah, this, and I think we are good to go. Let's now define the second function. I could simply copy this and change as I require. So class rectangle extending from the same. Let's do here width and double length. Yeah, so circle, let's do here rectangle, changing the names. And I want to actually also implement the compiler based polymorphism. So what I will do is if only one side is given, I will treat it as a square, and if both sides are given, I will treat it as a rectangle. So what I will do is double side, let's do width and keep it side. Then let's do a second for the pure rectangle one. Rectangle double side one, double side two, width side one as the width, and the side two as the length. Here also, and I need to do length also. So length side, yeah. think this is correct now. So the override is same, just changing the actual area calculation. We have to do width into length and the area of the rectangle is actually this. And also adding the close semicolons to finally end the function. Now let uh, like for demonstrating polymorphism, I need to actually create shapes. So what I will do is, firstly I will define let's define a vector which takes in input as shapes, and let's name it shapes only. Then what I can do is define the actual objects. So what I will do is let's object of a shape type shape. Let's name it O1, and it is equals to a new. Um, let's do circle first. So circle with a radius. Let's go with 3. Then I'm going to define a shape number 2. Let's do star. Think star O2 equals to new rectangle. Let's go with 3 only here also. So it's with this rectangle actually is a square here, which only has one side, so it will calculate according to that only. That is 3 into 3, which is 9. So shape for the last example, this will demonstrate the compiler based polymorphism, and O3 which is equal to new rectangle. Let's do 3a comma 4 so that the new area is 12. Then let's go on and add these shapes to my shapes list. Shapes dot push underscore back O1. Let's copy this. Uh, oh, sorry. So yeah, O2 and O3. Now that the shapes are added, let's now actually print the area. So what I will do is for auto n objects in the list shape, I'll actually print the area. So n dot print function which I defined for all of the above, this one. So it will override it and actually print for the each of them. So it actually shows us an example of dynamic polymorphism, which is all subtypes of the shape is actually uh, going into the actual child function, getting overridden and printing according to the child function only and not the parent function, which was actually not defined. So n dot print, and to close this we have to define a garbage character which is not auto defined in C++, but for Java it is already there. So auto n shapes, let's go delete n. Now I think we are done. Let's try and run this, see if there's any error. There are multiple errors it seems. So I forgot to close this here. Let's see if I have more errors. Hmm. Okay, so on line 50, I said shapes. Should be shape. Hmm. So now it is working correctly, as you can see. The area of the circle is 28.26. So 3 into 3, which is 9 into 3.14. 9 into 3.14 should be around something here only. So this is correct. The area of the rectangle is, which I defined as a form of a square, is actually 3 into 3, so that is also correct. And the area of the rectangle is 3 comma 4, which is also 12, so this is also correct. So as you can see, firstly I defined the abstraction here, which I did by defining the virtual functions: virtual double area, virtual void print, and virtual destructor. Then what I did was implemented the child classes, which was the circle one, which had encapsulation in form of this, the defining the radius, and defining the public functions, which were the area and the print, which was mandatory to implement. And I did that by overriding the parent classes function. Then I also defined a second class rectangle, which also inherited from the parent class shape. It also had some private variable width and length. I also added additional thing here, that is compiler time polymorphism, to showcase that I only defined instantiated two object the instantiator. I defined it two times, one with one variable and one with two variable, and both were fine. So yeah, and then finally I made a list of them, all the shapes, and push them into a singular vector containing all the shapes, and showcase the dynamic polymorphism. So yeah, that's all. Thank you.